All right, STAT1800. The purpose of this video is to introduce you on a very small scale z-scores. We will encounter z-scores and t-scores and different things we call test statistics later on. Again, purpose here is just to hit the tip of the iceberg on z-scores. So it's an extremely key concept. The z-score is a concept in statistics that provides to us a location of a data point. The first thing it addresses is the score above the mean or below the mean, and then how far away from the mean in standard deviations. So the way to measure this is called a z-score. The formula is pretty straightforward. We just take the x value, which is the score we wish to calculate the z-score of, and subtract the mean from it, and then divide by the standard deviation. And this will become much clearer, I think, when we start looking at some examples. So a couple of important properties about z-scores. Again, a z-score is measured in location in terms of the number of standard deviations that the score is away from the mean. If we have a positive z-score, then it means that the score is above the mean. If we have a negative z-score, it tells us that the mean, that the score is below the mean. Z-scores are expressed as numbers with no units, so they're just a standardized measure of unit. So one of the great things about z-scores is it gives us a tool by which we can compare scores from different distributions. So let's say that we have an ACT of 26. Let's say the mean this particular year was 22.5 with a standard deviation of 5.5. Let's say someone else took the SAT, they scored 1400. The mean that year was 1247 with a standard deviation of 188. Who scored the highest? Well, we can calculate a z-score for the ACT by taking the 26 minus the mean of 22.5 divided by 5.5, and we get 0.64. We can calculate the z-score for the SAT of 1400. So again, take 1400 minus the mean of 1247 divided by 188, and we get 0.81. So relative to their distributions, the SAT of 1400 was a slightly better score because its z-score was higher. So the interpretation, we can say that an ACT score of 26 is 0.64 standard deviations above the mean because it's a positive z-score. An ACT score of 1400 is 0.81 standard deviations above the mean. All right. IQ. Let's say we have an IQ of 142 and the mean IQ for a certain population is 103.5 with a standard deviation of 16.9. Again, the z-score is easy to calculate. Just take the IQ of 142 minus 103.5 divided by 16.9, we get 2.28. So our interpretation is an IQ of 142 is 2.28 standard deviations above the mean. Now, if that z-score had been negative, then we would be, whatever the z-score is, below the mean. All right, so let's take a look at something like that. Gestation periods. The mean gestation period is 266 days with a standard deviation of 16 days. Calculate the z-score for a gestation period of 225. Now, I'm expecting my z-score to be negative. Why? Well, because the gestation period of 225 is below the mean of 266. So I make the calculation. I take 225 minus 266, divide that by 16, I get negative 2.56. So the only difference in the interpretation of the z-score is I said that the gestation period of 225 is 2.56 standard deviations below the mean because the z-score is negative and the value Now calculating the z-score of 225 is below the mean of 266. All right, gang, that's all I got. Take care.